Hello viewers, welcome back to my YouTube channel Kasturi Shekhar Sir Classes for Mathematics and Statistics. In this video, I am explaining the concept of optimality test in transportation chapter. First of all, we have to calculate basic feasible solution by any of the three methods. Either you can use northwest corner rule or least cost method, otherwise Vogel's approximation method. Once initial solution is obtained, you have to verify whether it is the best solution or not. Fine. So what are the steps involved here? Step 1, calculate initial solution by any method. Step number 2, calculate UI and Vj for occupied cells Step number 3, calculate UI plus Vj for empty cells. Step number 4, calculate Dij matrix this is equal to Cij matrix minus Ui plus Vj for empty cells. Fine. If Dij values are greater than 0, the solution is unique optimal solution. If Dij values greater than or equal to 0, the solution is optimal but not unique. If Dij values are less than 0, the solution is not an optimal solution. So these are the steps we have to verify. Look at the steps once again. Calculate initial solution to the given problem by any of the three methods we have. Step number 2, to the initial solution obtained in step number 1, calculate UI and Vj for occupied cells, calculate UI plus Vj for empty cells. Finally, Dij matrix, this is equal to Cij matrix minus Ui plus Vj for empty cells. Now here you will get a matrix. In this matrix, if all the values are positive, then the solution obtained is unique optimal solution. Again I am repeating this point. If the values in the Dij matrix are greater than 0, means positive, the solution is unique optimal solution. Here Dij values are positive, but some of them are 0. Then the solution is optimal but not unique solution. Third point is, if Dij values are less than 0, the solution is not an optimal solution. These 3 points I'll verify when the given matrix is a cost matrix. If it is a profit matrix, these 3 conditions will change. Okay, let us see how to find an optimal solution to the given problem. Fine, I am considering a cost matrix and I'll explain all these steps one after another. This is my question. The numerical values inside the cells, means these values will represent transportation cost in thousands of rupees. Again, I am repeating this point. The numerical values inside the cells will represent per unit cost in 1000 rupees. Here, very first step is find the initial solution. So, using Vogel's method, I am calculating the penalties. Penalties are nothing but the difference between lowest cost and second lowest cost. 4 and 6 difference is 2. 2 and 3 difference is 1. 3 and 5 difference is 2. Row wise penalties are calculated. What is a penalty? How to calculate this one? I explained in my previous videos. Those who are watching my videos first time, please go to the playlist and watch the video in which Vogel's method I used for calculation of initial solution. 3 and 3 difference is 0. 5 and 6 difference is 1. 2 and 6 difference is 4. 5 and 5 difference is 0. This way penalties are calculated. After calculating the penalties, identify the maximum penalty. Maximum penalty is 4 rupees. Maximum penalty is 4 rupees. Corresponding to this 4 rupees, what is the least cost? 2 rupees. Means 2000 rupees. So I decided to supply the goods from second factory to third market. I decided to supply the goods from second factory to third market. See the availability at second factory 400. Requirement at third market is 350. We can fully satisfy the requirement of this market. We can fully satisfy the requirement of this market. Since this market requirement is fully satisfied, eliminate this market from the picture. Now this is the reduced cost matrix I have. Calculate penalties once again. For the reduced cost matrix, 4 and 6 difference is 2, 3 and 5 difference is 2, 3 and 5 difference is 2. Column wise penalties, 3 and 3 0, 6 and 5 it is 1 dash 0. Now look at this. All the three values for penalties are same. It means there is a tie as far as penalties are concerned. Then to whom I will select? First of all, I will verify what will be the cost corresponding to each penalty. What will be the least cost corresponding to these two? 4 is the least value. Corresponding to these two, 3 is the least value. Corresponding to these two, 3 is the least value. So completely ignore the first penalty. Look at this. These two. Here not only penalties are identical, means same, but also cost same. Then how can I select? Select the penalty through which maximum number of goods we can supply. Corresponding to these two, only 50 units I can supply to market 1. Corresponding to second row penalty, only 50 units I can supply to market 1. Corresponding to the third one, 400 units I can supply to the first market. So preference is given to these two. 400 units are supplied. Availability now reduced to 200. Market 1 requirement is fully satisfied. Eliminate this from the picture. Eliminate this from the picture. Next, calculate penalty 3. First row 6 and 6 difference is 0. Second row 5 and 5 difference is 0. Third row 5 and 9 difference is 4. Penalty column wise, first market requirement is fully satisfied. Penalty not required. 5 and 6 difference is 1. Third market requirement is satisfied. Penalty is not required. For fourth market 5 and 5 difference is 0. Now 4 is the maximum penalty. Corresponding to this 4, 5 is the least value. 200 units are supplied. After supplying 200 units, availability at F3 is over. Therefore, you can eliminate factory 3 from the picture because we cannot supply the goods from this factory to any market. Penalty 4, 6 and 6 0, 5 and 5 0, dash, this is 1 dash. Now sir, corresponding to this penalty 1, least value is 5. Corresponding to this penalty 1, also least value is 5. Here penalties are identical, means same, per unit cost also same. Then you can select any value. So I selected this. 50 units are supplied. This market requirement is reduced to 250 and availability at this factory is over. Eliminate this factory from the picture. Eliminate this factory from the picture. Now, goods are available at factory 1 only. Goods are available at a factory 1 only. Market 2 requires 450 units. Market 4 requires 250 units. Supply the goods. 450 units are supplied here. 0. 250. These 250 units are supplied here. 0, 0. Look at this. Availability at each factory is exhausted. At the same time, requirement for each market is also satisfied. Now verify whether it is a feasible solution or not. Number of occupied cells required. Is equal to number of rows plus number of columns minus 1. It is a 3 rows, 4 columns matrix. 6 occupied cells are required. Number of occupied cells obtained is equal to 1, 2, 3, 4, 5, 6. Therefore, it is a basic feasible solution. This is the procedure to calculate initial solution by Vogel's approximation method. Now look at this, sir. For performing optimality, certain calculations are required, and optimality test I am doing only to know whether the solution obtained here is the best solution or not. Okay. Step number 2, calculation of UI and VJ for occupied cells. Consider the occupied cells cost only. This is the cost per unit in the occupied cells. This is cost per unit in the occupied cells. For getting a unique set of UI and VJ values. Again I am repeating this point. To get a unique set of UI and VJ values, take any column index or any row index as 0. This third column is having a maximum of 3 occupied cells. Its index is taken as 0. 5 minus 0, 5. 5 minus 0, 5. 6 minus 0, 6. With the help of this 0, for these 3 rows, their index is calculated. How can I calculate? Inner value minus outer value. Inner value is 5, outer value is 0. 5 minus 0, 5. Once again, inner value 5, outer value 0, 5 minus 0, 5. Inner value 6, outer value 0, 6 minus 0, 6. Now corresponding to this 6, there is an occupied cell here. So 6 minus 6, 0. Next, corresponding to this 5, there is an occupied cell. Inner value is 2, outer value is 5. 2 minus 5 is minus 3. Corresponding to this 5, again there is an inner value 3. Inner value minus outer value, 3 minus 5 is minus 2. This way, a unique set of UI and VJ values are calculated. Remember, sir, very important point here. If I change the position of 0 here, these UI and VJ values will change. Again, I am repeating this point. If I change the position of 0, then my UI and VJ values will change. But don't worry, next step, that is when I am calculating the matrix UI plus VJ for empty cells, every one of us will get the same value. So my next step is calculation of UI plus VJ for empty cells. Put an identification mark in the occupied cells. Any sign you can write. It means you have to ignore the occupied cells and concentrate only on the empty cells. Now write the UI and VJ values obtained in the previous step. Same values are written here. Add these two outer values and write in the empty cell. Minus 3 plus 0 is minus 3. This outer value added, and I am writing here. Minus 3 plus 6 is 3. 0 plus 0 is 0. 0 plus 5 is 5. Minus 2 plus 5 is equal to 3. Minus 2 plus 6 is 4. This way, UI plus VJ for empty cells are calculated. Now the next step is your fate deciding step. In the sense, can I terminate the process or can I have to proceed further? That I will identify with the Dij matrix only. So this is step 4. Dij matrix is equal to Cij matrix minus UI plus VJ for empty cells. Now cost is taken from the given cost matrix. Here it is 4 rupees. Cij value from where will I get? From the given cost matrix. Minus UI plus Vj 4. 4 minus 4 0. Come to the first row, third column. You take a cost from the given cost matrix minus ui plus vj value. This is fine. Come to the second row, first column. 3 minus 3, 0. 5 minus 5, 0. Third row, second column, 9 minus 0, 9. 6 minus 3, this is 3. Look at this once again. 4 minus 4, 0. 8 minus 3, this is 5. 3 minus 3, this is 0. 5 minus 5, this is 0. 9 minus 0, this is 9. 6 minus of minus 3. This is 6 minus of minus 3. So this is 6 plus 3, 9. Dij values are greater than or equal to 0. So initial solution is an optimal solution. But not unique. This is the procedure for UV method to find an optimal solution for the given transportation problem. Do the question, watch the video 1 or 2 times if there is any doubt. For comments, you are welcome to give your comments. That's all in this video. Thank you.